Okay. Okay, welcome back. Sorry, the software I'm using to record this only gave me the opportunity to record in 10 minutes. So as I was explaining, we can say that point 1 is on a latitude 3 degrees and longitude 2 degrees. Similarly, point 2 can be regarded as being on latitude 7 degrees and longitude 6 degrees, or northing 7 northings and 6 eastings. So that's the concept of what a line is. 2 points or multiple points on the surface of the earth. By the time we join those points, it will now have what we call a line feature, and a line feature simply have a pair of coordinates like P1 and P2. Thank you. All right, now let's go to a polygon. Now polygons are formed by set of connecting lines, either one with an ending point that connects back to the starting point, or as a set of lines connected start to end. Polygons have an interior region and may entirely enclose other polygons in the region. Polygons may be adjacent to other polygons and thus share bordering or edging on edge lines with other polygons. Attribute data such as area, perimeter, line cover, type, or country name may be linked to each polygon. Now coming back to this diagram, now look at what is simply saying. You remember I said that a point has a single pair, a line has a multiple pairs, like 2 pairs, like P1 and P2 to form line. Similarly, a polygon now has multiple points, and these multiple points we can see here where we have P1, P2, P3, P4. Now when you join all these 4 points with a line, you now form what is termed as a polygon. And polygon is a vector data model. With polygons you can be able to trace things like your buildings, your structures, your trees, whatsoever you have on your design. And when you do that, you can be able to have a lot of data on there. We call them attribute data, such as the area coverage of that data, the size, the parameters, the name. You can give it a name, like for example, like you have street namings, you can use street naming polygons to do street namings, and a whole lot of other uses or manipulations. Now let's not forget that I said that everything you do on ArcGIS or QGIS, as far as it's a design, whether you're designing a route or you're designing a building, whether industrial, residential, whatsoever building, you are actually working with what we call vector data. You create them, you create vector data. Whereas there is what we call images on CAD platforms. Before you start any work, you need to have a base image. From that base image, you now create a base map of the study area. Now remember, in our manual studios, when we have a map, we scan the map to a scale. We scan the map, whether it's on A4 or whatever paper size. We now come and blow it to whatsoever scale we want, maybe from a scale of 1:200 to a bigger scale or whatsoever scale. Now we actually trace what is on that image. In GIS platform, you do the same thing. The only difference is that the image must be assigned with a coordinate system, which is what we call georeferencing. We are coming to that in the later classes. Once you have georeferenced or you have attached a geographical coordinate system to that image, you now begin tracing. You trace the routes, the footpaths, whatsoever, whether it's on top, the structures, whatsoever is there. Now the act of tracing those features on that image is called digitization. We are coming to that again. Now the image which you are using in order to trace these features is actually called a raster data. So now let's dive in to see what a raster data is. Please, we need to understand this key concept for us to be able to know how to use GIS appropriately. Mind you, I also said that it doesn't matter whether you're using QGIS or ArcMap or ArcGIS. The only issue is that you should know, just pick a particular software and master it and know how to work with it most appropriately. Whether you use QGIS, I use ArcMap, we can produce the same result. We can produce the same result because we are all talking about geographical system. It's coordinated, it has coordinate system that is on the earth surface, so it doesn't matter. So in this program we'll be highly utilizing ArcGIS. I'll try my possible best to make this a habit for us. We'll try to enjoy those classes. So I hope by now we understand what a vector data model is. From a point, you use 2 points or more to form a line, and you use multiple lines. When it's enclosed, you'll be able to define a vector data, a polygon data under vector. Okay, now so let me let's continue. Let's look at these figures. Now you can see this from this. This is a polygon. This is a polygon. Now this polygon has nodes, and the nodes is the same thing as the vertex. The vertex are the edges, at the end points of the polygon where lines intersect. Now from the points, we use lines to close this point, and by the time we close the point, we close it entirely from beginning. From this node, we go clockwise to this place, we close it back. We have now successfully formed what is a polygon. And now looking at the other side of the screen, this is a little image of a city. You can see the buildings, you can see the road connectivities and some trees. Okay, this is a perfect example. Here we basically use points to digitize or trace the trees, and we use lines to trace the buildings. We can also use polygon to trace the building, but if you use line, you won't be able to get the areas, or let's say the dimensions of those buildings. It's more appropriate to use polygons for your buildings in order for you to define the areas, whereas lines, we can use lines to digitize or trace our circulations and a whole lot of other stuff. Like you can use it to trace. When I say trace or digitize, I mean the same thing, to trace river body or water bodies and a whole lot of other uses. So that will be all for vector data. Now let's come to a raster data. What are raster data? Let me just give us a very simple explanation. As I said, when you are doing your manual studio, you first of all have a base image. From that base image, you now blow it to a scale, a bigger scale. Now that image in which you used to blow your map out before you start tracing the structures or the features to get your base map is actually the raster data model. The raster data model is basically comes in images. They are images. So now we'll say that a raster data model defines the world as a regular set of cells in a grid pattern. Now there's something we call pixels. Okay, resolutions. When you're using your smartphones, you see the smartphone comes with resolutions. Similarly, do you know that that image, when you take a snapshot of yourself or someone, or a selfie or whatsoever with a device or a smartphone, actually the smartphone does not read an image. What it reads small grid of cells, or a metric cells. Those are the metric cells that are being put together to form, we call them mosaics. Those little billions of pixels, little pixels that forms the grid, when they come together, it now forms what we call an image. You see it as an image. So that's how a raster data, that's what a raster data is all about. You see, supposing you have the image or the satellite, let's say the satellite image of your institution. Now you take it from Google Earth, for instance. Now you see it as an image. All the administrative blocks, the lecture hall, the roads and everything, they are all defined there. But mind you, the system does not see it as a building. It doesn't see it as a road. Rather, it sees it as a little pixel of grids, or we call them metrics of X and Y. Okay, so we say typically these cells are squares and evenly spaced in X and Y direction. The phenomena or entities of interest are represented by attribute values associated with each cell location. Raster data model are the natural means of representing continuous spatial features of phenomena, like elevation, precipitation, slope, pollutant concentration are examples of continuous variables. Now these variables are natural occurring entities. Now what we need to do, supposing for instance, if you are doing a vegetation cover or study, like you want to see the level of depletion of vegetation from, let's say, 2002 to 2020. Now the phenomenon that happens is a continuous, the depletion is an action. So the satellite image will be able to capture that data 2002. When you come to 2010, it can also capture that data. So it is a continuous special feature of phenomena. So raster data are good in capturing such data. That's a perfect example of raster data. Now Here is I got an image of a stadium in a particular city. You can see the stadium at the top left corner of my screen. It's showing you trees, structures, stadium, and open space or green land. Now, that image is what we call a satellite image.